Hello everyone! In this video we're going to be talking about some of the arithmetic that we can do in the C programming language. We're going to start with a little recap of the practice problem that we worked on at the end of the previous video. So this is our inches program. Remember, it figures out how many inches are in a mile. It starts with our header comment. Remember, the header comment is for our human readers. The compiler does not see comments. It's only for other people who are going to be reading our code to see what we've written. The header comment should include the name of the program and who wrote it. So this one was written by me, and the purpose of the program is to calculate the number of inches in a mile. That's followed by our preprocessor directives. So preprocessor directives have something important to tell the compiler. In this case, we want to tell it to include the standard input and output library. The standard input and output library gives us access to things like printf, where we can tell the computer to print something to the screen for our users. Right now, that's followed by the main function. C is a compiled language, which means everything that happens has to happen in a function, and the compiler will look for the main function as the starting point. So we must always have a main function, and that's always going to be our starting location for the program. Inside the main function, we start with our variable declaration and initialization. Remember, variables are what we store information in. There's 4 different types, but in this program so far, we've used integers. Each variable declaration starts with the data type. These are integers, so they use the data type int or int. That's followed by a name for the variable. And what you name the variable is important because it should give anybody reading the code an indication of what that variable is for. The one I have highlighted is called inches in foot, so very clearly it represents the number of inches in a foot. If we'd like to go ahead and initialize that variable, we can put in an equal sign and then a value. This initialization step is not strictly necessary for code correctness. You can see here in line 12, this variable, inches in mile, is declared as an integer and does not have an initial value. However, we do want to make sure that we have a value in our variable before we try and use it. And we can assign a value using an assignment statement. So right here in line 15, we're saying that variable, inches in mile, should be assigned the value that is equal to this expression. That's the number of inches in a foot times the feet in a mile. So this is our general assignment statement. A variable, then an equal sign, and then an expression. Now once we have our final value for inches in mile, we printed that out for the user. We called the print format function. This function is one of the functions located in the standard input and output library. So we call this function just with its name, print format. Then we have a set of parentheses, and inside the parentheses is what we want to print. We have this string. A string is anything between a set of 2 quotation marks. So we have this string that we print. It says the number of inches in a mile is some integer value. And each variable has a corresponding percent code that we can use for input and output. In this case, since we want to print an integer, we're going to use the integer percent code %d. We then have to tell the function where to get that value from. We'd like to get that from inches in mile, so that we can say the number of inches in a mile is this integer value from the variable inches in mile. Before we conclude the main function, we're going to include a return statement. And this one says, if we make it all the way to the end of this function, we will return 0 to say there are no errors. Here's a quick reminder. If we build and run, we should see as our output the number of inches in a mile is 63,360. So when we talked about variables, we said, variables by definition have to be able to vary. We can give them new values using an assignment statement. But in this practice problem, we're using 2 variables that don't vary. The number of inches in a foot is always going to be 12. And the number of feet in a mile is always going to be 5,280. These values don't change. So it would be more appropriate for us to store them somewhere that doesn't vary. For that, we can use something that's called a constant. These are defined values that never change. So instead of declaring a variable, we can define a constant along with our other preprocessor directives. So here's the general syntax. We have the pound symbol and the word define. So we're going to define a constant. We'll give it a name, and then we'll give it a value. So as an example, we could create a constant for inches in foot instead of a variable with pound define inches in foot with a value 12. Now you'll see here that I'm using all capital letters. This is what we call a stylistic decision. It's helpful to have a different style for your constants than your variables so that they look very different in your program. That way you'll always be able to tell which ones are constants and which ones are variables. So let's go back to our example program and we'll add in some constant values. Defining constants goes along with our preprocessor directives. We have the pound include for the standard input-output library. And we're going to add our constants here. We'll use pound define to define a constant. We're going to go ahead and call it inches. There's 12 inches in a foot. And 5,280 feet in a mile. So now that we have these values defined, we can use those anywhere we would normally use a variable in our expressions. So in main, we're going to take these values out because they're no longer necessary, and we'll replace this expression with one that makes use of our new constants. So the end result should be the same. Instead of variables, we're using these constant values, which remember are appropriate because these values are constant. They never change. To double check, we've got our changes. We're going to build and compile our program again, and we should see that the answer we get is exactly the same as the one that we had before. The number of inches in a mile is still 63,360. So the output, the end result of our program, hasn't changed any, just the interior pieces. Okay. Suppose instead of figuring out the number of inches in 1 mile, we wanted to figure out the number of inches in an arbitrary number of miles, like how many inches are in 3 miles? Or maybe how many inches are in 10.5 miles. In order to introduce that, we need to be able to ask the user how many miles they're interested in, so that we can always produce an answer based on their number of miles. In order for us to do that, we need to be able to get information from the user, which we're going to use our scan format function for. So right here we have the general syntax for that. Just like our print format function, this is the scan format function, and we'll call it using its name, which is scan format. It also has a set of parentheses, and in those parentheses we have a string, the comma, an ampersand, and a variable. So remember, we're using these triangular brackets to represent anything that is a similar or equivalent fit here. So this would be any percent code. Remember, there's only 4. There's %d for integers, %f for floats, %lf for doubles, and %c for characters. So depending on the type of information that we want from the user, we're going to use the appropriate percent code. If we want them to give us an integer, we'll use %d. If we want them to give us a real number, we'll use %f or %lf. Then we'll tell the computer where to put that information. We'll have to have a variable already declared to store that information in, and we'll put that here after the ampersand. The ampersand, or this AND symbol, stands for at the address of. So the user is going to give us some information, and we want to store it at the address of some variable. So here's a quick example. If we declared a number of miles as a float, which we would do if we want to have a real number like 7.5 or 9 3/4, then we would scan in the information from the keyboard using the % code that matches, %f matches float, and store it at the address of num miles, this variable that we declared for that purpose. Okay, so now we're going to go ahead and use this in our example program, and we'll update it so that we can ask the user for how many miles they're interested in, and then print out the number of inches in that many miles. So we're going to go back over here. This one's a little bit different from our inches program, so we're going to give it a new name. This will be inches 2. It's our second version of the program. And it calculates the number of inches in a user specified number of miles. So we'll ask them for that information. So of course, if we're going to ask the user for information, we have to have somewhere to store it. So we're going to create a variable that will support that. This will be num miles. The user will give us that information. And when we come up with a total number of inches, we'll still have that answer stored in the number, in the variable inches in mile. So the first thing we have to do is prompt the user for information. When we use a scan format function, it doesn't tell the user anything about the information we're looking for. It just gives them an opportunity to give us information. So we're going to use the print format function to tell the user what we're looking for. We'll let them know that we're interested in a certain number of miles. So we'll issue a prompt using our print format function. We'll ask how many miles, so that they'll know we're interested in a certain number of miles, and they will type that in, and that will be recorded as a float value that will store in num miles. So now we have access to that user information. We can calculate the number of inches in 1 mile, and then multiply that by the number of miles that the user actually gave us. Now when we print our output, we want to be specific that it's no longer the number of inches in a mile, it's the number of inches in the user specified number of miles. So we're going to say the number of inches in X miles is Y. We have to tell now the print format function where to get that information. The first % code is going to match the first value after the comma. So we'll just match these up this way. The number of inches in this many miles is this value, the second one. So the first % code matches here. The second % code goes here. This one is a float, so we'll use %f. This one is an integer, so we use %d. So now that we've made our changes, we want to check and see, make sure it looks the way we expect it to. So we're going to compile, check for errors, and then we'll run it. So when we run the program, it's going to start with this print statement up here. It says how many miles. and now it's waiting to finish the scan format function, and it will sit here and wait until the user provides some information. So to start out, if we want to make sure that it's working the way we think it should, we'll go with the one that we already know the answer to. Say, how about 1 mile? If we put in 1 and press enter, it's going to give us the rest of our output, which says the number of inches in 1 mile is 63,360. So that's information we've already seen a couple of times. So we know that that's right. So now we can run it again and tell it what else we're interested in, say 5 miles. If we run it with 5 as the input, then it'll tell us the number of inches in 5 miles. Now since num miles is a real number, we can also ask for the number of inches in 7.5 miles. And it'll give us that value as well. One thing we can also add to this is a way to make this value right here, the 7.500000 number, look a little bit cleaner. By default, it will print parts of a number to 6 decimal places. We can change that if we want to. There's some additional syntax that we can add to the percent code that tells it how many decimal places we'd like to print out. So of course this only applies to floats and doubles. Those are the only ones that have decimal places. So when we're using %f or %lf, we can add to it a period and then a number between the % and the f, or between the % and the lf, that tells it how many decimal places we'd like to print. So as an example, if we added period 3 between the % code and the f, then we'd print 3 decimal places. So we can use that to make this look a little bit cleaner. So remember, we're going to go in here between the % and the f of the % code, add a period, and then the number of decimal places we'd like to print out. So if we'd only like to print 2 decimal places, we'll use %.2f. So now when we print out that value, the number of inches in 8.60 miles is this value. We told it to print 2 decimal places, so it only printed 2 decimal places in 8.6. Okay, now that we've seen all of the basic pieces, variable declaration, input from the user, assignment statements, and output, we're going to try something just a little bit more complicated. This is a trapezoid. And at some point in time, you probably sat through a geometry class where you had to figure out the area of a trapezoid. So I've copied that formula right here. Area of a trapezoid is 1/2 a plus b times height. What we're going to do is we're going to build a program that will calculate the area of a trapezoid for a user if they provide the values for a, b, and h. What we're going to do first is declare our variables for a, b, h, and area. So we're going to come over here and create a new program that calculates the area of a trapezoid. In our preprocessor directives, we're going to be sure to include the standard input and output library to make sure that we have access to the print format function and the scan format function. The only constant in our equation is 1/2, so we could declare that as a constant, but right now we're going to just include it in the main function so that we can demonstrate a couple of things about how arithmetic works in C. That means we'll just go on to the main function, where we'll do all of the similar steps as before. Declare variables, ask the user for any necessary input, calculate the result, and then print the output. That's all that's necessary for the main function, so we'll return 0 at the end. So you see at the moment everything's black and white. This happens until you save the program as an actual C source file. So right now it's untitled, so we don't have any of that syntax highlighting. This is our trapezoid function, so we're going to go ahead and save that as trapezoid.c, and now if you watch, as soon as we save it as a C source file, we get all of our syntax highlighting back. Okay, so first up we're going to declare variables. We're going to declare a variable for A, B, H, and area. And we're going to allow the user to enter real numbers, which means we need to either use floats or doubles. I'm going to use floats. Got A, B, H, which represents the height, and the final answer, which is area. If you're declaring more than one variable of the same type, you can do that all on the same line by separating each variable name with a comma. So this will declare all 4 floats for us, A, B, height, and area. Now we need to get our information from the user. We're going to prompt them and ask for the value of A, the value of B, and the height. And after each question, we're going to go ahead and wait for their response. Each of these are floats, so we're going to put inside a set of quotation marks the % code that matches floats, or %f. What we're essentially telling the computer is that we'd like to wait for the user to enter a real number. The scan format function will wait until a number is entered on the keyboard. And then we're going to tell it that we would like to store it in this variable A. And we're going to repeat that for each piece of information we're trying to read in. So for A, B, and height. So there's our 3 values. Here's A, B, and height. And now we have all the pieces that we need for our equation. So now we're ready to calculate the result. We're just going to get this from over here. Here's the formula. We're just going to use that to figure out what area is. So area is going to be equal to 1/2 times A plus B times the height. So this is just a simple assignment statement. Remember, we've got our variable, then the equal sign, and then the expression. So it's just our expression that's getting a little bit more complicated. 1/2 times A plus B times height. And then we're ready to print the output. We're going to give them both the answer and a little bit of context. So we're going to say the area of your trapezoid is this real number value printed out to 2 decimal places. And we want that value to come from area, the one we just calculated in the line before. So we're going to run this program. We're going to see a slight issue with it, and I'll tell you why after we've taken a look at it. So we're going to compile and check for any compiler errors. Then we're going to run. So it's going to ask us for some values, and we're just going to make some up real quick. And it's going to tell us that the area of our trapezoid is 0. That's not right. Right, so if we take 3 and we add 4 to it, divide by 2, and then multiply by 5, we may not know what the answer is off the top of our heads, but we know it's not 0. Well, this is a result of what's called integer division. And the C programming language treats integer division separate from real division. When you divide integers, you always get an integer result. If you want a real number result, you have to make them real numbers. So this is an example of what it looks like. If 12 is an integer, and you divide it by 4, which is an integer, you get an integer value. The same is true if you take 13. If it's an integer and divide by integer 4, you get an integer result. Even though this should be 3.25, all we see is the integer portion of the answer, 3. Same story here. If we take 14 and divide it by 4, instead of seeing 3.5, we just see the whole number portion, the 3. And that remains for all of our values. We don't see the next value up until we actually have that whole number. 16 divided by 4 is 4. So in our program, we're taking 1, which is an integer, dividing it by 2, which is an integer, and getting an answer of 0, because 2 goes into 1 0 times. So what we're essentially doing here in line 23 is 0 times a plus b times height, which is why our answer is coming out to be 0. There are several ways to fix this problem. Essentially, what we need to do is make one of these not an integer, and that will cause us to do real division. What we might do is something called casting, and this allows us to temporarily change the data type of a variable or an expression. So 1 divided by 2 is an expression. And all we're going to do is, in a set of parentheses, indicate what type of value we would like that to be. By default, it's an integer, but we can make it become a float value or even a double. So here's a quick example. If we have an integer x equal to 19, we can cast it or temporarily change the data type of x by putting double in a set of parentheses right in front of it. So this will temporarily change x into being a double so that when we divide it by 6, we do real division instead of integer division. So we're going to go back to our program and we'll fix that. We can change this value instead of being the integer 1 divided by the integer 2, which gives us integer 0 as a result. We can cast 1 to become a float value. And then we have real number 1 divided by integer 2, which will give us the real value 0.5. So now if we compile and run, even if we give it the same inputs as before, since we're now doing real division, we're going to get a real answer. Precedence in C programming works very similar to the way it does in algebra. Anything that happens in a set of parentheses happens first. So in our practice program, since a and b are encapsulated in a set of parentheses, that happens first. First we calculate a plus b. What follows that are the casts, and casts are also in parentheses. So casting happens next. So after a plus b, the cast happens where we make 1 a real number instead of an integer. Everything else proceeds algebraically. We're going to do multiplication and division in order from left to right. So we'll do 1 divided by 2 first, then multiply it by the resultant value, a plus b, then multiply it by height. If there's any addition and subtraction, that happens afterwards. Same level of precedence, also from left to right. Now it's your turn to give it a shot. Given the formula below, write a program that will ask the user for the radius of a hemisphere and calculate the correct volume. Check for your data types. Make sure when you prompt the user for information, you tell them what type of data you're looking for. and then read it in using the correct percent code. Follow the formula, and print your answer to 2 decimal places. When you finish, you can check the web course for my solution to the problem. And we'll talk about it a little bit more in the next video. See you then!